Okay, let's expand this a little bit. Alright, so let's look at page 13. So I'm looking on page 13 here, and we've got P1V1 equals P2V2. I don't think you're ever going to have to know this is Boyle's law. You won't have to memorize that, or this is Charles' law, or anything like that. What you will need to know is how to work stuff out. So ultimately, this is the combined gas law. What pressure is required to confine 0.460 moles of an ideal gas at 33 degrees Celsius in a volume of 9.5 liters? So we have pressure is what they're asking us for. We have moles, we have 33 degrees Celsius, and I don't know why Boyle's law is written up there. But the first thing, always, 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 write down your givens. If you will write down your givens, it makes it easier to figure out what equation you're going to do and what we can get here. So first of all, they ask us point blank what pressure is required to confine 0.46 moles. So we have number of moles is 0.460 of an ideal gas at 33 degrees Celsius. So they give us a temperature of 33 degrees Celsius and a volume of 9.50 liters. Is this the combined gas law? No. Yeah, look at this. It's not the combined gas law because you don't have two pressures, two temperatures, two volumes, two moles at all. So they've given you information about a particular gas, and they're asking you, hey, what's the pressure we're using to confine this? So in this case, we use the ideal gas law. PV equals nRT. Learn to solve the equation. You guys are advanced math classes, things like that. Rearrange the letters of the equation so that before you put numbers in it, so that you've got a nice clear equation. I want P by itself, and these two are multiplied together. What's the opposite of multiplication?
Division.
So we divide out V. If we do it on both sides, it cancels like this. So my new equation becomes P equals nRT over V. Plug my numbers in. I have P equals, so now I can plug my numbers in. So I have N is 0.460 moles. And I like to put parentheses around. I know I got 2 decimals, leave me alone. So I have N, R. I need to look on my chart. I have options for my R. So look on your green pages. And our temperature is 33 degrees Celsius. Our volume is 9.50 liters. If we look at R, typically we choose the R that our pressure is in. Since they're asking us to find pressure, then we can pick whatever R we want. I suggest strongly you pick the one that has atmospheres in it. So your R should be 0.08206 liter times atmospheres divided by moles times K. So liter atmospheres over mole. Your T is 33 degrees Celsius. Can we leave it in Celsius? No, you must change it to Kelvin, so add 273. I got 306, is that right? And look at this a minute. In our R, we have a Kelvin temperature. It has to be in Kelvin. If it's not in Kelvin, our temperatures won't cancel out. So I have my N, I have my R, I have my T, all divided by my volume, which is 9.50 liters. And if you look in our R, there's liters right here. If you look at this then, just look at your units of measurement. I have a liter on top of a fraction and a liter on bottom of a fraction, they cancel. I have a mole on the bottom of a fraction, a mole on top of a fraction, they cancel. I have K on bottom of a fraction, mole on top, K on top. The only unit of measurement that doesn't cancel out is atmospheres, and that's exactly what pressure is measured in. So when you put this into your calculator, open your parentheses here, pop all your numbers in, close your parentheses here, hit divided by, and then hit that number. Unless you want to put it in your calculator in pieces. let me move this over some. So 0.46 divided by times 0.08206 times 306 divided by 9.5. You got 1.216. How many sig figs? 3 sig figs? I'm seeing 3 sig figs too, I agree. So 1 point what? 1.22, what's my unit of measurement? So 1 atmosphere would be room temperature, right? So this is above normal atmosphere that you typically feel right now. Okay, turn the page. And again, anytime you need to pause the video, then do that. If you turn the page here, it's easy to distinguish between solving a problem by the ratio method or by using the ideal gas law. If the conditions change, use the ratio method. When they say ratio method, they're talking about combined gas law. The ratio of P1 to P2 and so on. So determine what volume 1 mole of a gas at STP would occupy. Use the ideal gas law if there's a constant set of conditions. Do you see what they're saying here when they word it like that? So they're just telling you again, look, how do you determine if you're going to use the ideal gas law or the combined gas law? If you have the combined gas law, you have the conditions that change, the pressure changes or the temperature changes or the whatever changes. If you have the ideal gas law, you just have one set of everything here. So again, first step, always, always, always write your givens. Your hand is not going to cramp up when you write your givens. It's not. Nor is your brain going to fry because, oh my gosh, I've had to write more stuff here. Write your givens. If you look right here, determine what volume. They're asking you volume. They've given you 1 mole. At STP, STP tells you temperature and pressure. So my temperature is 0 degrees Celsius and my pressure is 1 atmosphere. Can't do squat with that temperature in Celsius, so add 273. Am I going to use the combined gas law or the ideal gas law? Ideal gas law. So PV equals nRT. Solve the equation for V. So when you solve the equation for V, you're going to divide out pressure on both sides. So V equals nRT over P. Yeah? Plug your numbers in. Okay, don't be afraid to use the units of measurement. A lot of times we get sloppy and we just want to do, oh, there's a 1, there's a 273, there's a 1. You know, we don't get sloppy with it. They give you credit, and I can't pick and choose when, but they'll give you credit for showing the correct work. A lot of times, almost always, they'll give you credit for showing number of moles, or if you have to calculate that. So don't be shy about showing your work here. So our pressure's in atmospheres, so the R is 0.08206 liter atmospheres over mole. And then the T is 273 K, all divided by the pressure, which is 1 atmosphere. Again, when I put it in a calculator, which this one's kind of easy to do here, open parentheses, multiply all your numbers, close parentheses, divided by. So basically it's 0.08206 times 273, right? Because we really don't care about the ones. Oh my gosh, do you recognize that number? 1 mole of any gas at STP, 1 mole of any gas at STP takes up 22.4 liters. So when you look at this, we have 1 mole at STP. We don't even care what gas it is. 1 mole at STP takes up 22.4 liters. 1 mole of any gas at STP is going to be 22.4 liters. There's your number right there. You just proved it. Okay, the next one says calculate the density of oxygen gas at STP. Well, let's write down what they gave us. It says calculate density. And remember, density is equal to mass divided by volume, right? They also gave us a temperature and a pressure. T is equal to what? Mm-hmm. 273. So temperature, it's STP, standard temperature and pressure. So it's 0 degrees Celsius or 273 K. And the pressure is what? 1 atmosphere. Okay, I gave you a unique equation for dealing with density in gases, didn't I? Cats put dirt over their pee, right? Yeah. So you could use this. You could not. You could do this in various ways. There are more possibilities and different ways to do this. So you could do this with cats put dirt over their pee and density, right? Yeah. However, let's look at this in a straightforward PV equals nRT. Right? PV equals nRT. Okay. Now here's our volume. We want M over V, right? The only place we can get grams is from the number of moles, yes? Yeah. So that's what we want to aim for. So you can try and rearrange that, or what you could do, and I think this might be simpler for you guys to think about this too, you might try for number of moles. You could do this. It takes more steps if you don't use that cats put dirt over their pee. That's what I'm telling you. So if you will use that equation, then it just makes it a little bit easier. But you could use this one, and you could try and figure some things out. But if we use molar weight, and remember molar weight is grams per mole, right? So we have cats put dirt over P. Do we have density? No, we don't. Can we solve for density? Because that's what they're asking us to find. Can you rearrange the equation so you can get D by itself? Yes. So multiply P out on both sides, right? So if we multiply by P on both sides, we get this, right? And then if we divide out by RT, so we get pressure times the molar weight divided by R over T. If you look at this right here. I can take this as a chunk. If I want D by itself, if I take this chunk and flip it upside down, then I've got P times MW divided by RT is equal to the density. Yeah? Okay, so what do we have? Do we have a pressure? So I'm going to go right up here, okay? We have a pressure. So the pressure is 1 atmosphere. Do we have the molar weight? Oh, look at this. It's oxygen. What's the molar weight of oxygen? O2. 32 grams per mole. See, when we do this one, they're going to have to tell you what gas it is. Do we have R? Yeah, 0.08206 liter atmospheres over mole. And do we have T? Yeah, 273 K. All that is going to be equal to the density. Pop that into your calculator. Again, if I'm putting this in my calculator all at one time, open parentheses, multiply these two numbers, close parentheses, divided by, open parentheses, multiply these two numbers, close parentheses. Sometimes I feel kind of condescending when I tell you guys to put the parentheses like this, but I still have people that struggle with that. Yeah. Now, look at this a second. When you have this times this, you know it's 22.4 liters, don't you? Yeah. There's your 22.4. It keeps popping up. 1 mole of any gas at STP is going to be 22.4 liters, so it kind of pops up there. But yeah. So you've got 1.428. How many sig figs?
I don't know. Is it 2 or 1?
Okay. Did they give us any numbers in here? They didn't give us any numbers in the problem, did they?
No.
We can choose our own sig figs. So yeah, so 1.428, and its density, so it's grams per liter. Now look at this. Atmosphere, they cancel. Moles cancel. K canceled. So we have gram on top, we have liters on bottom. So grams per liter. Okay, once you've written that down, go ahead and take a break. And I'll stop this video and make it a shorter one.